Okay, this is just like the example that I did in class, but I promised to do a more thorough one and more detailed breakdown. So in this equation, again, we're doing phenol, we're doing a combustion reaction. So we're going to have phenol, which is some combination of carbon, hydrogen, and oxygen, is going to go into, so we're going to react it and get CO2 out and water. And we're told that the CO2 mass is 14.67 grams, or milligrams, sorry, and that the water mass is 3.01 milligrams. And we're told that our original sample has 5.23 milligrams of phenol. So what this means is that I should actually have room here and write in excess oxygen plus this reaction gives that, because if you notice, these masses are considerably larger than this. Okay, so our starting point is to look at this and say we have these three masses. So conservation of mass, whatever carbon I have here, if this completely combusts, means that that is the amount of carbon I began with. And whatever hydrogen I have here means that's the amount of hydrogen I began with. So if I can come to the masses of these two, subtract that from the mass of this, then I can get to the mass of oxygen that I originally had, which is good. So our little road map here, let's go from mass of reactants, to mass of elements, so carbon and hydrogen, to percent composition. And we're going to get from here to here using our understanding of molar mass. So let's start with CO2. So we want moles of CO2. Oops, CO2. Not an exponent. So we have a mass of CO2. We have 14.67 milligrams of CO2. I'm going to get that in moles. I'm sorry, in grams. So I'll just do my unit conversion right away. 1,000 milligrams in 1 gram. Oops, not equals. Now I want to get into moles. So my mass will be up on top. I'm in grams. So if I just find the molecular mass of this, then I can have moles of my carbon dioxide. So my molecular mass is the 12.0107 grams of carbon. So there's just one atom of carbon plus 2 times my 15.9994 grams of oxygen and 1 mole of CO2. And I'm running out of room, so I'm going to write an equal sign and bring it on down here. So this equals 0.12333 moles of CO2. But I need to get into moles of carbon so I can get into mass of carbon. And you can do this in one line if you don't write as big as I do. And you can just fit it all nice as punch, it's fine. So we come over here, I'm just going to start a little further over the left, 0.00033 moles of carbon dioxide times, there is 1 mole of carbon and 1 mole of carbon dioxide. So 1 mole of carbon and 1 mole, 1 mole of carbon and 1 mole of carbon dioxide. Caught myself, because they have to cancel, otherwise I'd have moles of carbon dioxide squared and that wouldn't work. So I want moles of carbon. Now I can get into my mass of carbon. And my mass of carbon is going to, the mole will go on the bottom, 1 mole of carbon, and there are 12.0107 grams of carbon per 1 mole. And this gives me 0.004004 grams of carbon. Circle that. Now, there is a little bit of a shortcut that you can get away with if you're very comfortable with this, and I did not do that. By skipping this conversion, you can see that this is actually 4.004 milligrams. And seeing as we're in milligrams up here, you can do that so long as you are really sure of what you're doing and what your units are going to be when they come out to the end. Because your unit analysis won't work if you just simply go from milligrams to grams. So I know it's a shortcut and it saves you writing that and then doing this last little step of saying, so okay. So carbon is 4.004 milligrams. Now what about our water? So I have moles of water, is what I'm aiming for here. I have 3.01. I won't do that. I won't just jump. 3.01 milligrams of water times, do my conversion, 1,000 milligrams in 1 gram times, now we want to get into moles, so grams up on top, there are 1 mole. Oops. Let's do the molecular mass. There are 2 hydrogen, so 2 times 1.00794 grams plus our oxygen mass, 15.9994 grams, and 1 mole of H2O. So let's check our units out. Milligrams cancel, and grams, so we'll be in grams of H2O, will cancel with our grams, and will indeed be in moles of H2O. That here. Okay. So this gives us 0.123167 moles of H2O. Now I want to go into grams of H2O, so I can go into grams of hydrogen. I'll start back over here. 0.1, make sure you can see, 0.123167 moles of H2O times, for 1 mole of H2O, there are 2 moles of hydrogen. Okay, 2 hydrogen in this 1 mole times, now we want the molecular mass. Now I didn't go into H2, into elemental hydrogen, because we don't have elemental hydrogen in our phenol compound. We only have hydrogen. So it's really important that I have this in hydrogen instead of H2, otherwise I have to make a little correction at the very end. So we have this, so our moles of H2O cancel, we're in moles of hydrogen, times 1 mole of hydrogen has 1.00794 grams of hydrogen. Check it out, moles cancel here, and we are indeed in grams of hydrogen. So this gives us 0.123337 grams of hydrogen, or 0.337 milligrams of hydrogen. Let me box that. So we have milligrams of hydrogen there, we have milligrams of carbon. So now we're ready to do the mass of the oxygen, which is simply going to be our 5.23, whoops, 5.23 milligrams of the sample minus the carbon, 4.004 milligrams, minus the hydrogen, 0.337 milligrams, and I'm going to make a note here that we're doing oxygen. 0.337 milligrams gives us a mass of what? Gives us a mass of 0.889 milligrams. 0.889 milligrams of oxygen. So now it's just a simple percentage. We have all of our parts and pieces. We have our milligrams of oxygen, we have our milligrams of hydrogen, and our milligrams of carbon. So now carbon is just the 4.004, as you can see, 4.004 milligrams divided by the total sample mass of 5.23 milligrams. We're going to multiply that by 100. And I'm going to do the same thing with my hydrogen. I have 0.337 milligrams of hydrogen divided by, we don't need that, the total mass of the sample, 5.23 milligrams. Multiply that by 100. And finally our oxygen. I can go 0.889 milligrams of oxygen divided by the total mass of the sample. That times 100 gives me, let's see, 76.6% carbon, 6.44% hydrogen, and the leftover is 16.96 or 17.0% oxygen. There you go. So the only other step that we haven't done with this is turning these milligrams. You could turn these into moles and then do an empirical formula from there by dividing by the smallest mole. You could do the step, now we've done this, you could turn this into 76.6 grams out of 100 and turn that into moles, and then divide by your smallest mole. So this is really the last little step. Or if you'd kept track up here and done it in steps, you would already have your moles of the carbon and the hydrogen. You would have just needed to have done the extra step for oxygen. And of course, you might be looking at this step and saying, well, that's silly. Why didn't you just figure out what these are and subtract that from 100? You can do that too. So a lot of different ways to do this, and there's just one more.